Hello and welcome to this video that is designed to go through the recent topic test that we had on algebra, specifically equations, and this is for my Year 8 group. So in the class we actually went through the multiple choice section. I'm going to leave that there, I'm not going to worry about that one, and instead I'm just going to focus on the short answer questions that came at the end of the topic. Now this is the first video I've done using this software and using some new hardware that I've bought today. So it may be a little bit slow selecting the right options that I've got on my screen. So apologies if it takes a little bit longer than usual. As with anything, practice it, get better at it, and pretty sure after a while, these videos will be nice and quick, nice and easy to follow. So what's the idea of this video? The idea of this video is that you can use it to review your exam, review your performance, and get some feedback at your own pace on the correct way to solve these equations. This way, hopefully, you'll avoid having someone go really fast, i.e. me. You can't write down everything in time, you can't write and listen, you can't rewind what I say in the classroom. This gives you those options, hopefully makes it more manageable. Also, I am hoping that it means you don't have to listen to me talk about something that you already know how to do. You can just scroll through the video, find the right thing, get the answers to the things you got wrong, and then move on. Try something new, try something difficult. Because at the end of the day, we don't want you wasting too much time on things that you already know. So, try listening to the explanations for the things that I've done correctly. Some of them have got more than one right way to do it. So if you feel like there's another way you tried to do it and don't understand where you went wrong, there's still the class time. Speak to me. I'll try and spot your mistake. Hopefully I've already circled it on your test paper already, but this is just an extra resource for you. So if we start off with the first question, question 11 that we've got here, we need to write an equation and then solve it. The product of 7 and 5 more than a number is 14. Pretty tough actually for people to set up this equation correctly. I thought that would be the hard thing for people. It does work out that way. Most people would find this difficult. So we need to put into maths what we've got on the left. So the first part is the product of. The product of means a multiplication. So the multiplication of two things. The first thing we're given is 7. So 7 multiplied by something. Then we've got this tough part, which is 5 more than a number. You can see I've missed with the pen the first time. Hopefully we'll get that right. So we don't know what the number is. So what do we do with that in algebra? Well, we give it a letter. Sometimes n, sometimes x. I'm going to use n here just because it always doesn't look like an x. But it's not 7 multiplied by a number. It's 7 multiplied by 5 more than a number. Well, if we know what the number is, how do we find 5 more than it? What we do is we add 5. So we've got 7 times by n plus 5 is equal to 14. Of course, in algebra, when we've got a number multiplied across a whole bracket, we don't use the multiply sign. So we're just going to erase this here. We're just going to be left with 7 n plus 5 equals 14. How do we solve this equation? Well, the first step is to see, is this number on the left a factor of this number here? Yes, it is. So let's divide both sides by 7 to start with. To save space, I'm just going to write it on the edges here rather than underneath. Dividing by 7 cancels out the timesing by 7. We just got an n plus 5. 14 divided by 7 is 2. This is a number plus 5, so if we just want the number on its own, we have to subtract 5, because that cancels out the plus 5. That'll just leave us with an n, and 2 take away 5 is minus 3. Okay, so that's the first one. And we'll scroll down a little bit to question 12. We need to solve each of the following equations. The first one, part A, is that a plus 12 is equal to 15. One step, a number plus 12 is equal to 15. We want to undo the adding 12, so we take away 12 from both sides. Gives us a is equal to 3. Part B, we've got p divided by 8 is equal to 5. What's the opposite to dividing by 8? The opposite to dividing by 8 is timesing multiplying by 8. So multiply both sides of the equation by 8. P is 40. Finally, we've got 6 multiplied by P is equal to 100. What's the opposite to multiplying by 6? It is, of course, dividing by 6. So we divide both sides by 6. That leaves that P is equal to 100 over 6. Important thing here is, of course, fractions are numbers. There's no need to convert that to a decimal. 100 over 6 would get you full marks. You can just leave it there. If you want to simplify the fraction, 2 is a common factor at the top and bottom, so you can have 50 over 3. Don't try writing it as 16.6 recurring. People tend to get that wrong. They lose marks because they wrote down the answer that wasn't correct. So stick with fractions here. Okay, moving along, 13. Question 13 is difficult because it involves negative amounts of pronumerals. That's what we're testing here. So what we've got is that 8 take away x over 2 is equal to 2. What we've got to remember here really is that this 8 has got a positive sign in front of it that we haven't bothered to write. So what we've got to find x is we've got to get rid of the things on the equation in the right order. We want to get rid of the plus 8 first. So we need to subtract an 8 from both sides. That'll leave us negative x over 2 is equal to 2. No, it's not. There's the first error. All right. 2 minus 8 is, of course, minus 6. So remember here, the minus belongs to the x over 2. The minus doesn't belong to the 8. That's where most people are going to go wrong. So what does negative x over 2 mean? Well, it means x divided by minus 2. So to find x, we want to do the opposite to dividing by minus 2, which is multiplying by minus 2. We do the same things to both sides, gives us an x, and negative 6 times by negative 2 is positive 12. 2 negatives multiplied make b positive. B is pretty similar. We've got minus 3 is equal to 25 minus 14a. As with before, we want to deal with this addition first. We want to get rid of the plus 25. So we want to take away 25 from both sides. A lot of people go wrong with minus 3 minus 25. Use a calculator if you need to. Minus 28. And that leaves us with minus 14a. Once again, the minus sign goes with the term on the right. Now we know what a multiplied by negative 14 is equal to, so we need to do the opposite to multiplying by negative 14, which is dividing by negative 14. 28 divided by 14 would be 2, and it's a negative divided by negative, which is positive, so 2 is equal to a. Okay, some maths teachers might insist that you have the pronumeral on the left, so you have a is equal to 2. I wouldn't penalise you at this stage. Bear in mind, it's something other teachers may ask for in the future. Okay, so moving on to question 14 now. We've got a couple of equations that actually are very similar to one we did earlier. So we've got 6 lots of a plus 7 equals 60. Once again, we check, is 6 a factor of 60? Yes, it is. So let's divide both sides of the equation by 6. On the left-hand side, that just leaves the a plus the 7. And 60 divided by 6 is 10. So we know what a plus 7 is equal to. So to find what just a is, we need to do the opposite to adding 7, which is subtracting 7. We do it to both sides. So we're just left with an a, and 10 minus 7 is 3. B, 2 lots of x minus 4 plus 10 is equal to 22. What have we got here? Well, it looks a bit more complicated than A, and it is, but really all they've done if you compare it to the start, so if I just have a look on the left, we had 6 lots of a minus plus 7. Here we've got 2 lots of x minus 4, and then they add a 10. So the extra step they've done is adding a 10. Well, let's just undo that extra step of adding 10. Let's just start by subtracting 10. What does that leave us? Well, on the left-hand side, it just leaves us the 2 lots of x minus 4. On the right-hand side, it leaves us 12. So now this looks like what we solved in part A. We know how to solve these, it's quite easy. So we start by checking is 2 a factor of 12? Yes, it is. So great, we'll just divide by the 2 both sides. On the left, we've got x minus 4, and that is equal to 6. All right, so we know a number take away 4 is equal to 6. What's the number? Well, we do the opposite to taking away 4, which is adding 4. Do it to both sides, so x is 10. It's worth reminding you, you can use substitution at this point to check if your answer is correct. What do I mean? Well, I mean, try that x is equal to 10 in this original equation and see if it gives you the value they're expecting. So in other words, we have 2 lots of 10 minus 4 plus 10, we want it to equal 22. So using our order of operations, we do the thing in the brackets first. So we've got 2 lots of 6 plus 10 equals 22. 2 times 6 is 12. Add the 10, it's 22. So what we're left with is 22 equals 22. Is that true? Yes, it is. So our answer was correct. And that's when I talk about checking your work at the end of the test. That's what it looks like. Substitute the numbers into the original equation. Do you get the right answer? Okay, so 15 is a bit longer. It involves division. Division is always a little bit harder and more than 2 steps. Now we're looking at sort of 3 or perhaps even 4 steps as we move along. So in part A, we have got 4x minus 6 divided by 2 is equal to 7. Notice the last thing I said was divided by 2. So when we're solving this equation and backtracking, the first thing we need to do is cancel the dividing by 2. So we're going to start by multiplying both sides by 2. On the left-hand side, that leaves us our 4x minus 6, and 7 times 2 is 14. Now this is a nice 2-step equation. We already know how to solve these. We need to deal with the addition first because it's 4 lots of x, then take away 6. So doing that backwards, we need to deal with the take away 6. We add 6 to both sides, just left with 4x there, 20 on the right. Let's divide that by 4. So we're just left with an x, and 20 divided by 4 is 5. Okay, B, the setup is slightly different. You can see it just from the question. The divides part is much smaller than in part A. And that translates to how we say the equation as well. So we would say this equation as 9 lots of x divided by 5, then add 7 gives you 25. So the last thing that I said there was then add 7. So when we backtrack to find out what x is, the first thing we undo is the adding 7. So this time we're going to start by subtracting 7 from both sides. On the left-hand side, that leaves us 9x is over 5 is equal to 18. There are 2 ways you can do this from here. I'm going to show you a couple of ways. I'll show you the way that I think is easier first. So the first thing we can do is to say that this is 9 lots of x divided by 5, or it's x divided by 5 multiplied by 9, because if you know your odd maths order of operations, you know that division and multiplication, they're on the same level. So it doesn't matter which order you put them in. So if we start by dividing both sides by 9, then we'd have x over 5, and we would have that is equal to 2. 18 divided by 2 is 9. Now we've got x divided by 5, so we times both sides by 5, and we get that x equals 10. So that's the first way. Doing it the other way, we carry on with our reading as it's 9 lots of x divided by 5, So we undo the dividing by 5 by multiplying both sides by 5 to leave us 9x is equal to 90. And now we divide both sides by 9. And we get that x is equal to 10. So same answer, two different ways. When you do the division first, the numbers are a lot smaller. It's easier to do in your head. When you do it with the multiplication first, dealing with that, the numbers get a bit bigger. But if you've got a calculator, you might not be too fast. You can kind of see the effect of this more when we look at question C. So it's quite a long one. It is really, if we sort of set it up perhaps from over here, a number plus 15, then multiplied by 12, then divided by 11 is equal to 120. So if we just unpick that using the backtracking method, rather than perhaps the shortest one first, well, multiplying by 11 both sides, we would just be left with 12 lots of x plus 15 is equal to 1,320. Then we want to divide that by 12. So I'll put that back in this time, divide by 12. Again, I'd use a calculator here. So x plus 15 is equal to 110. That is nice and simple. We just need to take away the 15. So x is equal to 95. Easy peasy. Okay, so we have moved on to question 16. What is this testing? It is testing if you know how to solve equations where there are pronumerals on both sides. Okay, so I kind of talked about this, well, a little bit earlier, mostly in class. What we really need to do when we've got pronumerals on both sides of the equation, so a positive 1a and a positive 5a, is we always want to get rid of the smaller amount of a's first. So here, on the left-hand side, we've got just 1a. On the right-hand side, we've got 5a's, which is smaller, 1a. So the way we get rid of 1a is to take away an a. I have to do it from both sides. On the left-hand side, the a plus the 7 take away the a, or the a take away the a, they leave nothing, they cancel out, so we're just left with a 7. And 5a take away 1a is 4a. We've got 4a minus 1. To save all the space, I'm not going to write all these other individual parts underneath, as you see there's 4 questions here. So what we now need to do is we need to backtrack to find out what a is using the techniques we've used previously. This is a multiplied by 4, then take away 1. So we want to add 1 to backtrack and undo the take away 1. Adding 1 gives that 8 is 4a. And then dividing by 4 gives us that 2 is a. Okay, b, 2x plus 3 equals 4x plus 1. Here, what we're testing is, do you remember that you need to expand the bracket on the right-hand side first? So this is 4 multiplied by everything in the bracket x plus 1. So the 4 multiplied by the x is 4x. The 4 multiplied by the plus 1 is plus 4. Then we go back and do what we did in part A. Okay, which is the smaller number of x's? Well, we've got 2x on the left, 4x on the right. 2x is the smaller amount, so let's take away a 2x from both sides. When we do that, on the left, we've got 3. 3 is equal to 4x minus 2x, 2x, plus the 4. Do a similar thing to what we did immediately before in part A. Take away the 4. 3 take away 4 is minus 1. Then we divide by 2. Once again, avoid decimals, don't need them. So it's negative 1 divided by 2 minus a half, how you might say that. And that's okay, that's our answer. So minus a half is equal to x. C is pretty much the same as B, but what are we doing at the start? Well, we're not expanding one bracket, we're expanding two brackets. Sorry, the pen didn't quite catch those. So we do 4 times 3k gives us 12k. 4 times minus 1 is minus 4. 5 times 2k is 10k. 5 times plus 1 is plus 5. What's the smaller amount of k's? Well, there's 10 on the right, 12 on the left. 10 is smaller, so we're going to take away 10 from both sides. So to save space, 12k minus 10k is 2k. The minus 4 isn't affected. So 2k minus 4 is equal to just the 5. Positive 5, but we don't really need to write the plus anymore. So I'll just kind of leave that out for now. Just erase that one quickly. It is there. Okay, so we add the 4. 2k is equal to 9. Divide by 2, k is equal to 9 over 2. So again, don't need to worry about decimals, they don't matter. Part D, I'll just put here on the left. So x squared is 1.44. Similar to the multiple choice, you have to remember when we've got a squared option, there are two possible answers. One is positive, one is negative, but they will both be the square root of 1.4. When we do that, use a calculator, you might know it in your head, that is 1.2. So x is positive or negative 1.2. Just tidy up the decimal point here. Okay, 17. We are getting into the really tricky ones now because it's giving you words and asking you to write equations from it. Most people find this really difficult, so don't worry too much. This is one of the things you need to practice, and it's in the syllabus even in sort of years 10, 11, 12 sometimes. As with most things in maths, the more you do it, the more you get used to it, the easier you'll find it. So, question 17. For the following, find the equation and use it to solve the problem. There's a stick, it's 2 meters long, it's broken into 2 parts, who knows why. One piece though is 16 centimeters longer than the other. So let's say that makes it a short piece and a long piece. I am going to use S to be the short piece. So the short piece plus the long piece, L, is equal to 200 centimeters. That'll make it slightly easier to deal with because the pieces are in centimeters when they're measured. So let's turn these 2 meters over here on the left to centimeters as well. Okay, this is an equation and we've got 2 unknowns. So that's not really going to work. We're not going to be able to solve this. So what we're going to say is, well, the longer piece is 16 centimeters longer than the short piece. So the long piece is whatever the short piece is. So if the short piece is S, then the long piece is NS, but it's plus an extra 16. So what have I done here? I've taken this L and I've broken it up into an S plus 16. Okay, so now I can collect the like terms. One S plus another S will give me 2 lots of S. 2S plus 16 is equal to 200. Okay, now this is an equation we can solve. We know how to do this. This is a 2-step equation. So S multiplied by 2, then plus 16 is equal to 200. Backtrack to find S. We want to take away 16. Oops, sorry, so I've got ahead of myself there and written the answer. So take away 16. So 2 lots of S is equal to 184. Divide that by 2, we get that S is 92. So the short piece, so the pieces, sorry for the handwriting there, so the pieces are 92 centimeters is the short piece. And the long piece is 16 centimeters longer than that. So what's 92 plus 16? It is 108 centimeters. So the two pieces are 92 centimeters and 108 centimeters. If you add 92 and 108 quickly, you'll see that does make 200. So you know it's a valid solution as well. All right, question 18. You can use algebra. You might not use algebra. I'm going to show you the algebra way to do it. It's up to you. You might not want to use it. So Rehan gave the shopkeeper $10 to pay for 6 snack bars. He then receives $2.20 change. How much does each snack bar cost? Well, the obvious question is, why is Rehan buying 6 snack bars? Why isn't he buying a more balanced meal for the day? But we'll gloss over that one for now. As with most maths questions, they have kind of weird scenarios to come up for. Okay, so let's say, how much does each snack bar cost? Well, if the cost is something we want to find, let's call it C. Might as well. So he bought 6 of these. So he got 6 lots of the cost of the snack bar. If you add on the $2.20 in change that he got, it would give you his starting amount of $10. So this cost of 6 snack bars plus the $2.20 in change comes up to his total starting amount of $10. To solve this, we are going to backtrack. So we're going to minus 2.2 and say that 6c is 7.8. I've put the 0 on. You don't need it at this stage. Then we are going to divide by 6. Divide by 6. So c is 1.3. So that's what your calculator would tell you. C is 1.3, but it's a cost, so we don't leave it that way. We use units. So we say that the cost is $1.30. Okay, you could have just done it by saying that $10 minus $2.20 equals $7.80. So he spent $7.80 on the snack bars. $7.80 divided by 6 equals 1.30. So the cost is $1.30, and get the same answer that way. You might prefer that way. If it's a pure equation though, what we've got on the right is how we're going to solve this. Okay, so nearly there. Solve these number problems by first writing an equation. So 4 less than twice a number is equal to 20 plus that same number. Okay, so let's use n for our numbers. So part A. So 4 less than twice a number. The order of this is important. So we need to think, well, it says 4 less than. Am I going to do that first? Am I going to put in a minus 4 here? Not really, because it's 4 less than twice a number. So we need to think about, well, how do we write twice a number? If we know a number is n, twice that number is 2n. If we want 4 less than that, we take away 4. And it's equal to, well, I know how to write is equal to in maths. That's easy. Just do it with these 2 bars. 20 plus that same number. If the number was n before, the number is n here. Okay, to save space, I'm not going to write down all the things that I'm doing, just going to talk through them. So we've got 2n on the left, 1n on the right, so we get rid of the smaller 1n. So we take away 1n from both sides. 2n minus 1n is n. We've got n minus 4 equals 20. Then we've got the number take away 4. So to get the number, we add 4 to both sides. N is 24. And that's our solution to part A. So if you were to put that into the original equation, 4 less than twice the number. So 4 less than twice 24. Twice 24 is 48. 4 less than that is 44. Is equal to 20 plus that same number. 20 plus 24, 44 as well. So 44 equals 44. That's what we were after. B is a bit harder. remembering how we write consecutive numbers in algebra. So the two consecutive numbers, the sum of them means they're added together, and it results in 109. So what we need to remember is, well, what are consecutive numbers? A consecutive number is the one that's one bigger than the number before it. So 5 and 6 are two consecutive numbers because 6 is one bigger than 5. 99 and 100 are two consecutive numbers because 100 is one bigger than 99, and so on. So 400 is and 399 are consecutive numbers. The point is, though, if you know the starting number, n, the consecutive number that comes after it is one bigger than n, which we write as n plus 1. In the equation, it tells us we want the sum of these two numbers. So the sum of those two numbers means if they're added together, we get 109. So n plus n plus 1, we can simplify that. N plus n is 2n, plus a 1 is equal to 109. Take away 1 from both sides, we get 2n is equal to 108. Divide by 2, n equals 54. What does n represent, though? Well, n was the starting number. It was the first number out of the two consecutive numbers. If it says the sum of two consecutive numbers results in 109, what we're really wanting to know is, well, what are those two numbers? The smaller one is 54. The consecutive number, the one that comes after it, is one more than 54, 55. So the numbers are 54 and 55. Okay, and we're on the last question. Paid with a 1 question on it. Slightly frustrating, but what can you do? This is really hard, this one here, and it is something that most people didn't do correctly. That's no surprise. It's the very last question. So let's draw a diagram. So it says a triangle that has the base length equal with its height has an area of 128 square millimeters. So what have I got? I have got a triangle, not drawn to scale or particularly accurately here, where the base length, let's call that b, and the height are equal. So let's just use that notation to show that these two things are equal. The height meets the base at a right angle. We know that. That's how we define those two things. And it's got an area of 128 square millimeters. So we need to determine the dimensions of the triangle by first writing an equation. Well, we're given the area, so the equation that we're going to use is going to involve the area of a triangle. What's the area of a triangle? Well, the area of a triangle is a half times the base times by the height. But the important thing is what it tells us in the question and what we marked on the diagram is that the base length is equal with its height. So whatever b is, it's the same as h. Similarly, whatever h is, it's the same as b. So what I'm perfectly justified in doing here is saying that the area is a half times b times b, because the height is the same as the base. So I could replace an h with a b and it will still work for this particular triangle only. This isn't a general rule, but it's based on the information that we're given. We're told it's 128, so the area is 128, so I'm substituting that value in, and that is a half times the base times by the base. But something multiplied by itself, we've got a shorthand for writing that in maths. We write it as b squared. So b multiplied by b is b squared. This is now looking like a quadratic equation that we've solved before. Except usually what we've had is we've just had b squared or x squared or n squared or something equal to, and we haven't had it multiplied by a half before. So when you think about how could we get it equal to just to b squared? Well, this is b squared times by half. What's the opposite to timesing by half? It is, of course, dividing by half. So let's divide both of these by half, and we'll find that 256 is equal to b squared. So usually when I solve these quadratics, I would say that b is equal to the positive or negative of the square root of 256. Just clean up that 6. What I remember though at this point is that I'm finding a length. A length is not going to be negative. There's just no way. So kind of similar to Pythagoras' theorem, we don't actually worry about the plus or the minus here. We just concentrate on the fact that it's going to be the positive square root of 256, and we don't worry about the negative option. You might know that off the top of your head. Great. If you don't, put it into your calculator. It gives you that b is 14. Or 60, of course. Its length, and it's in millimeters, so it is 16 millimeters. And that's the solution to the hardest one on the question. So it does actually say determine the dimensions of the triangle. The base is 16 millimeters, so the triangle has a base of 16 millimeters, and the height is the same as the base, so it has, and the height 16 millimeters. Alright, that's the end of the video. I hope you found it useful and you've got something out of this more than so than you might ordinarily get out of it in class. If you've got feedback, please let me know in class or send me an email. Like I said, if you want any clarification on these other things, the way I've solved it doesn't work for you, that's totally fine. Also, bear in mind that this topic test is for the whole of Year 8. So, of course, there are always going to be things at the end that are going to be really hard, and they're even designed to make sort of set 1 really struggle and really think about what they're doing. So, don't panic at this early stage. There's plenty of time to practice these. Okay, thanks very much.